Welcome to our tech workshop. My name is Jian Lange. I'm a product manager for spatial analysis at Esri. This is my colleague Vicky Cove. Vicky works for the geoprocessing team. This is our third year to do this tech workshop. Really, every year we try to mix in with different demos. It's a demo-heavy workshop. We're actually one of our favorites. We're really having fun presenting this workshop. So the topic is to apply spatial analysis techniques. It is sort of an overview session. We're trying to mix in different products available at Esri. Analysis being a key capability of ArcGIS. It is across the platform. It is pretty much in every of our products. So it is not possible for us to cover all aspects of it. So I'll start with a highlight, an overview of what we offer in analysis for ArcGIS, and then how we position analysis. And then the focus of this tech workshop is really the second part. We want to show you different examples and demos so that you get an idea how you can apply different analytical techniques to solve real-world problems. And our goal is also to mix different products from online to enterprise to desktop, so that to insights, so that you get an idea of different analytical experience. Overview. So a brief description of what spatial analysis is. So spatial analysis is really to apply geospatial technique such as spatial statistics, modeling to solve problems. By doing that, it helps us to gain value from your location or spatial data. Therefore, it helps us to make better decisions or take the right actions. Here are some examples of the type of problems that analysis help us to solve. Understanding where. This is about geo-enable your data. Geocoding. Put those data on your map, symbolize it in a way that you can better visualize it and understand it. Determine how things are related. This is about spatial relationships. How close are they? Are they on top of each other? Can you see it from one place to another? And connect access to it. So proximity, intersection, visibility, accessibility. These are all about how things related spatially. Find the best locations and paths. It goes very self-explanatory. This is probably the most classic problem that spatial analysis helps to solve. Detect and quantify patterns. This is about spatial distribution. Find clusters in your spatial data, identify hotspots, cold spots, and outliers, and also understand how the spatial pattern change over time. Finally, make predictions. This is to use advanced modeling techniques such as statistics, machine learning algorithms to forecast future events based on the data we currently have. So what are some of the top trends that we're observing on the analysis, in the analysis area on the market? This is closely related to what we plan for our product. So first, we see more and more people have a need to process large amount of data. So the data is so massive, it cannot be processed by one single computer. It needs a distributed approach. Our users' data has both space and time, so they would like to add the temporal dimension into their spatial analysis process so that they can better understand how things change over time. Users also would like to be able to visualize and analyze large volume of observation data in real time. Data visualization, this is a hot topic these days. This includes having creative ways to visualize your data so that it can review patterns. So this is part of the exploratory data analysis. Visualization also includes how to visualize your analytical results. So we're not talking about just showing numbers and static maps. We're talking about having interactively linked maps, charts, and other elements. Some people perceive analysis being difficult and complicated, so we're always asked to make it more intuitive, requires less development, allows experts to be able to share their workflows online that make it available to other non-GIS experts. So all these will help us to bring the power of analysis to a new audience, to a wider audience. We're also observing a trend in data science and analysis. So more and more of our users showing interest in prototyping applications in integrating artificial intelligence, machine learning into ArcGIS, especially in the area of predictive analytics. So the top message is ArcGIS is a comprehensive analytical platform, from data preparation to developing or deploying a model to collaboration. So we provide out-of-the-box analytical tools from simple to advanced across the platform. And in ArcGIS, there is an analysis experience for everyone. We have the professional desktop suite, ArcGIS Pro, which includes comprehensive analytical capabilities for 2D, 3D, and through time. And with the analysis and geoprocessing capabilities in ArcGIS Pro, you can pretty much perform virtually any type of spatial analysis. We have analytical tools hosted in the cloud, available in ArcGIS Online, as well as on-premise ArcGIS Enterprise. We also observing a new way of delivering hosted analytic services with the authoritative content. So these are workflows like network services, so you can create an optimal route without having to worry about the network dataset. The dataset comes with the service. Another example would be geo-enrichment service or hydrology elevation service. Available for both ArcGIS Online and ArcGIS Enterprise, ArcGIS Insights takes an interactive approach to spatial analysis. So you can do dynamic analysis through drag and drop tools. Vicky will show a demo later on. We believe that this intuitive user experience from Insights becomes very attractive to analysts, especially those who are not trained GIS analysts. For data that's too big to be processed on one single computer, we have a GeoAnalytics server available for enterprise, which allows you to perform spatial temporal type of analysis, leveraging distributed storage and processing. So similarly that's for vector data, so feature data. So similarly for raster data, you can scale up your raster analysis using image server raster analytics in a distributed environment. For real-time analysis, we have a product called GeoEvent Server, which will support analyzing data for a stream of real-time data, and this so that we can better understand ongoing observation data patterns, and also makes full use of IoT investment. So having said that, so these are all available for the ArcGIS platform. So they are interchangeable in many ways. So let's, for example, real-time analytics GeoEvent server, they store this large this archive, this large volume of observation data in this spatial temporal data store, and that is shared by the geoanalytics server. You can then perform big data analysis on this data. Some analysts, especially data scientists, they're used to the scripting environment. So for those analysts, they can use the ArcGIS Python API to do geocoding, spatial analysis, big data analytics on both vector and raster data, and they can do that all in the scripting environment using ArcGIS Python API. And ArcGIS Python API also supports Jupyter Notebook, which is a popular environment by some data scientists and analysts. And with that environment, they can integrate additional machine learning libraries or scientific Python packages. So with that, and also our integration of R in ArcGIS, this provides a good opportunity for collaboration between the data science community and the GIS community. So although this is a very powerful way to enable machine learning, it's not the only option. So more and more tools, ArcGIS tools, are added into our platform based on machine learning algorithms. So some of the image classification tools uses the deep learning libraries, third-party libraries, but incorporated into the tools. We have released some clustering tools based on machine learning algorithms, as well as the latest release of classification prediction tool based on random forest. I'm going to show a demo on that. So finally, we also have focused analytical solutions, such as business analyst. So those solutions were designed with some specific market sectors in mind. So having that, so that set the context of analysis overall in ArcGIS. So from the analysis team, our goal is always to advance spatial data science. We want to help our users to solve their problems, and we would like to provide the best methods possible for problem solving. We also want to make it more intuitive, easier to use, with smart defaults. So we want to make complex things simple so that more people, everyone in the organization, can perform the data-driven analytics. Of course, it's always our goal to deliver quality product, more stable, better performance. So with that, I'm going to pass it over to Vicky and start showing you different examples.
Thank you. Can everyone hear me, or is that okay? So I'm going to start off with a demo using spatial analysis in ArcGIS Online. So did anyone here come to the Intro to Analysis in ArcGIS Online workshop that Jian and I did on Tuesday? I think I saw a couple hands. Anyway, if you did, thank you for coming back at 8:30 on a Thursday. And for the rest of you, thanks for coming out anyway. So ArcGIS Online is a really good place to do a lot of your analysis because it is based through the cloud and in a browser. So you don't have to install any software and you don't have to maintain anything. It's all done by Esri. It also means it's easy to collect your data. It's easy to share your analysis. It's easy to collaborate and communicate because it's all through a browser. So I'm going to do a suitability style analysis using ArcGIS Online. So in this analysis, it's based on disaster response. So in recent years, we've seen a lot of increases in natural disasters, things like hurricanes, flooding events. In this case, we're going to look at Houston, which had a large hurricane last year with a lot of flooding. And we're going to see how we could use GIS to help with either responding to the event when it's happening, the flooding event, or after it's already happened. So we're going to do something like a suitability analysis where we're going to collect the data, decide on some criteria, and then do a query on that data to see where it all fits together. But instead of finding actual suitable locations, we're going to be using it to determine risk locations. So it's going to be the same steps, but sort of a different outcome in the end. So I've started off with 3 different layers that were all, I found them all just by searching for layers in ArcGIS Online, and I guess browsing the Living Atlas as well. So I have my City of Houston boundary, which you can see around here. That was from the Living Atlas of the world, and I just did a filter on the urban areas so that it's only Houston showing. My demographic data, which is these census blocks here, this was available from Learn ArcGIS. And my flooding, which you'll see here, this was available as an Esri layer through ArcGIS Online as well. So to start off, I want to know what types of criteria I'm going to use for my suitability analysis. So I'm going to open up my demographic layer, and I'm looking for something that's going to make it a higher risk area based on evacuation. So we know when there's flooding events, there are often mandatory evacuations, and some people have a harder time than others evacuating. So the data that I have here includes things like population and age, but it also includes a field with households without a vehicle. And that can be a limiting factor for a lot of people not having a vehicle to actually do that evacuation. So that's the field that I want to focus on in this analysis. Of course, there are other things we could use as well, like age or disability or things like that. I'm just going to focus on vehicles for this. So I'm going to need a criteria that I can set a level of a number of households without a vehicle that's going to make it higher risk. So I'm going to look at the statistics for this field, and I see the average number of households is 110, and the standard deviation is 108. So those are the numbers that I'm going to use, and you'll see me going through that a couple different times, and I'll remind you what those numbers were as we go. So I'm just going to turn this off so you can see the flooding a little bit better. And then I'm going to start to build our query. So we're also going to want to use this flooding as part of our query. So in my analysis, we have tool sets, and they sort of show what types of tools are in each, and they're grouped to find similar types of tools and make it easier for you to find what you're looking for. I'm going to use the Find Locations toolset, and there are sort of 2 options that I can use in a suitability analysis: find existing locations and derive new locations. They're pretty similar. You can do attribute and spatial queries in both, combined all at the same time. But in find existing locations, you're going to return full features. So if I input a bunch of polygons, then the ones that fit the criteria will be returned to me exactly as they were in the input. With derive new locations, it's going to look at the exact spots where the criteria fit, and then it's going to extract those out into new shapes. So for a suitability analysis of something like retail locations, you want to find the best spot for your new store. You might want to use find existing locations because it'll keep the plots of land or the building footprints how they were. But for something like flood risk, I'm going to use derive new locations because I want to see the exact spots where the flooding and the demographic information overlap. So I can open this tool and start creating my expression. And I'm going to start off using an attribute query. So I have this where clause, and I want to look at the demographic data and the renters and homeowners without a vehicle is going to be greater than 218. And I got that number by adding that average of 110 and the standard deviation of 108 to make 118 or 218. So I can add that. Then I'm going to start doing some spatial queries as well. So I'm going to look at where my demographics are going to intersect my flood areas. I can add that. And then the final one is that I want to keep it within my Houston boundary. So I'll put in the demographics again, intersect, and my Houston boundary. So now I have a full query, and what's going to be returned are the areas with the highest number of households without a vehicle that are within my flood areas and within my city. So I'm not going to run these tools just to save a little bit of time. But if I just go and show you the results that I created, and I've styled them already, we have the highest risk areas, and I've made them red to show they're high risk. And you see that they're overlapping with the flood areas, and they're inside that city boundary. Now what I can do, if I want to see different levels of risk, is I can go to this layer that I created, click Rerun Analysis, and it's going to open up that tool pane from when I ran that analysis in the first place. And I can just select this attribute query and edit it. And I'm just going to change it now so that instead of being greater than 218, I want to look at between 110, the average, and 218, that average plus the standard deviation that I used last time. So now I've edited that tool. I could run it again. And then I'll have areas that have a medium high risk, and I've symbolized them with a slightly different red color. And I can keep doing that. So I've done it again with medium low risk, and I'll just show you the pane that I used to create that one. So here, if we look at our attribute query, I've changed it to between 2 and 110. So that's the average 110 minus the standard deviation 108. So that gives us our lower standard deviation area. And that gives us our medium low risk area, and that's in the orangey yellow color. And then my low risk area, the final one that I'm going to do, I've just changed it to less than 2. So that's the 110 minus the 108. Anything less than that is in the lowest risk area. So now I can turn off my floods. And this is the result we have of the entire flooding area and what the risk is within that entire flood zone. So something I could do with this, now that I've had this analysis, I could save this web map. I could share it and put it into an app, and then maybe responders on the ground would be able to use that when they're looking for people who haven't evacuated, if they're looking to bring supplies for people who were unable to evacuate. We could find data like hospitals or nursing homes and overlay that onto this map, use it more as like a base map, and find where are places we need to respond the quickest. And there are all kinds of things you could do like that. So this is sort of like the base map of the analysis and how we could use that in the response. And it just sort of depends on what you want to do with it. So I'll just do a brief recap of what I just did in that demo. So we added the data, we added the demographics and the flood areas. We also had a boundary. We calculated the statistics on our demographics to see the average and the standard deviation. And then we used derived new locations 4 times to find different levels of flood risk. And then we reviewed our results and thought about what we might use this map for in a real world situation. So the next demo I'm going to use is Insights for ArcGIS. And I'm going to do an analysis understanding the refugee crisis that is happening in the world right now. So this might be something if you're from a humanitarian organization, a government official, a journalist, if you just want to take a look at what is happening in the refugee crisis. So just briefly to explain a little bit about Insights, it is an app that right now I'm using it through my ArcGIS Online organizational account. If I had an enterprise account, I could also use the app through that. And it is a way of doing powerful analysis, but making it easy. It's interactive, it uses drag and drop, and it can do fast and powerful analysis as you think of it. So that's why I'm going to do an analysis where I'm exploring data and trying to just find out new things about it to see where I can go from there. So I have my UNHCR data, which just includes the year, which is 2017, the country of asylum, the country of origin, and the number of refugees that move between the two countries. And I have a world countries there from the Living Atlas, which I used to apply the shapes to my Excel file, which I downloaded from the UNHCR website. So I started off with just an Excel file and then used the data in Insights to create a spatial data set. If you want to see me do that, maybe talk to me after. I'm not going to show you during this demo. So to start off, these are the types of maps you might be familiar with looking at the refugee crisis. How many refugees are from different countries. We have just a proportional symbol map. That's the type of thing you might see on the news, but there's a lot more that we can do in Insights than just that. So what I want to show you is link analysis, which is a brand new thing that we've just started using in Insights for ArcGIS. So I'm going to take both the country of origin, country of asylum, and the number of refugees. And just as a side note, if you use other ArcGIS products, you might notice there are multiple shapes within this data set, and that is unique in Insights. So I have both a shape for the origin and the asylum. And I'm going to just drag that over onto my page and create a map. And this is called a link map. So I know this looks like there's a lot going on here, but don't worry, it's going to get a lot easier to understand. So if I open up the information about this, you'll see that we start at the country of origin and go to the country of asylum. And I'm going to just change the style of these nodes to make it a little bit easier to see. I'll take out the fill, and then I'll change the color here. And the links I'll make a little bit lighter just so that they're not overpowering the nodes. And so with link analysis, you have a set of nodes and you have sets of links, and they're showing the relationship between the two. So the nodes are all styled by a centrality, and right now it is showing the out degree, which is the number of connections, direct connections to from the origin to the country of asylum. So that's why you see countries like New Zealand, Australia, Canada, the United States are relatively small, whereas country, something like Russia is a little bit bigger. There are more, you're going to more countries of asylum from there than from the other countries. I'm just going to switch this to the in degree, and now we're going to see instead the number of countries coming from a country of asylum into the coming from the country of origin into the country of asylum. So that's why now we see those same countries have kind of switched, and Australia, New Zealand, United States, Canada are a little bit bigger now. So now that I've talked a little bit about that centrality, I'm just going to change our links back so that we can see them a little bit better. And I'm going to create some tables, and we're going to use those tables to show more specific information on our link map. So I'm going to take a country of asylum and the number of refugees and create a table. Just going to zoom out a little bit so I can show everything on this one map. And then the country of origin and the number of refugees and create another table. And I'm going to apply cross filters to all of the cards. And a cross filter is just a way of doing a filter by selection. So if I use all of the same data set on all my cards, I can make a selection on one card and it'll filter the other cards. So just to show you how that works, I've sorted my tables to the countries of asylum. We see that Turkey here has almost 3.5 million people seeking asylum there. So if I click on Turkey, it's going to filter that link map. So it only shows the countries that are seeking asylum in Turkey. So I can zoom in and I can see the patterns of the countries that are closest to Turkey are the places that have the most refugees seeking asylum there, as we see from the thickness of the links. And also in my table here, we now see the tabular data as well, with Syria having over 3.4 million of the asylum seekers in Turkey. I can also look at some of the other countries that have high numbers of refugees. A different area would be Uganda. It has the same sort of pattern, although fewer countries of origin, but it is the neighbors that are the most commonly seeking asylum there. But if we look at a country like Germany, which also has a high level, we see that the asylum seekers are coming from all over the world. So if I just expand this here a little bit, you can see they're from everywhere. And a slight difference with Germany versus the others is that the highest number is actually from Syria, which is not one of the neighbors. So there are more people coming from further away into Germany than from nearby. So something else we could do is if we want to look at the countries of origin. So we can look at Syria, which most of us, I think, probably have been hearing a lot about the Syrian refugee crisis for several years now. So if we look at Syria from 2017, we see that people from Syria are going all over the world. Again, sort of like the opposite of with Germany. They're going all over instead of, in Germany's case, coming from all over. And that highest number being in the neighboring countries. But if we look at a place that has a newer refugee crisis emerging, like Myanmar, we see it's slightly different. The pattern we're seeing is not quite as worldwide. There's still a large number of Western countries, but it's not the same pattern that we see with Syria. So if I zoom in here, I can also look at some of the other information that we're not maybe seeing from this recent crisis. So Bangladesh is the highest number of refugees entering from Myanmar, which I think anyone who's following this has probably heard that. But something we don't hear as much about is Thailand and Malaysia, which have both accepted almost 100,000 refugees from Myanmar. But because Bangladesh is so much higher, it's getting the main focus. So I'm just going to go over, just review what we did in that demo. It was mostly exploratory. We didn't necessarily find out specific new information, but we saw new ways of visualizing that data and seeing some patterns. So we added our data from the United Nations High Commission on Refugees from 2017 and our countries. And then we created some maps, and then we also created a link map, which is that new feature in Insights. And we created tables and applied cross filters, and we used those to look at patterns across different countries of origin and countries of asylum. And then looking at our results, we saw how different countries have different patterns of accepting refugees or of going to countries of asylum. So just before I hand it over to Gian, I'll mention if you're interested in seeing more demos from Insights, there is an advanced Insights for ArcGIS Advanced Topics workshop today at 2:30. It is in room 33AB. And there's also the Insights Island, which is located in the Spatial Analytics section of the expo, not in the apps section. So then I'll just pass it over to Gian now.
Thanks, Vicky. Okay, that was great. So moving on, what I'm going to show is how you can do some analysis in ArcGIS Pro. So my goal is to show you some out-of-the-box tools. How many of you are using Pro currently already? Okay, great. So the first part is just get you familiar with the environment, see how you can use some tools out of the box. Then I want to show a just simple example of how we can automate that workflow using Model Builder, and then how we can create a script tool I'm using Python to do the same automation. So I'll just get started. So my example here, this was a fire in the San Bernardino mountain area that happened, I would say, about 3 or 4 years ago. And it was a fire that burned for about 2 weeks and had a lot of damage. So I just downloaded the fire boundary data from the USGS website. So here I have multiple days. So let's just use the bookmark to see this is the day 1 of the fire. And then that's when it started. And then let's go to the last day when it was at its peak. Did I click on it? Yeah, that's the last day. So as you can see, it grew quite a bit. So my goal today is to analyze how this fire has changed over time, and then also what kind of impact it has to the local recreational activities, also what are the affected population. So let me open the attribute table of my fire boundary. So these are the information I have when I download the fire boundary. So obviously I want to analyze how the fire area has changed over time. So the first thing I need would be the area for each day. So what I will do is if you're familiar with Pro, so you do always go to the analysis tab. When you do spatial analysis, you go to the tools. So what I want to do first to add the area. There's a tool called Add Geometry Attributes. I want to add the area to my table. So my input feature would be fire boundaries. And what I want to add is the area. Let's add it in acres. And then go ahead and run this tool. There you can see that my area is now added to my table. So the next thing I would like to do is I would like to calculate what's the percent change from one day to the previous day. So I need to first have a field in my table that capture that percentage. So I'll do, these are some simple analysis tools. So I'll just say add a field. Add it to my fire boundaries, and the field name, I'm just going to call it percent change. And it's going to be a double number, which captures decimal points. So I just say, go ahead and run this. So now the field is added. So next step is I'm going to calculate that percentage. So I'm going to go calculate field. So in my calculate field, I want to use the fire boundary table, and the field I would like to calculate is the, where's my percent? Let me double check. It's always a risk doing live demos. Double check. Here's my percentage change. Let me see. Let's go from this way, calculate field. Okay. So my field is the percentage change. So I'm going to use this useful helper function. Here I can see there is a function already called percentage change. And I said like that, it gave me the hint, the format. So I want to say calculate the percentage change based on my area field. Let's call that. I suspect there's some problem. It seems like I can't edit that field. Hold on, let me go and try it. So I think what happens is it's probably still in editing mode. So now it's live debugging here. Let's do that. See. Okay, let's do it one more time. Calculate field. there's some permission issue. It wouldn't allow me to edit that. Let me just do this. I give it one more try, then we'll just move on. Air boundaries. Okay, let's see. That. Okay, let's give it one more try. Okay, here, percentage change, calculate field. Okay, percentage change. Now I would like to do the percentage change. And then it's area geo. Going to go ahead and run it. It works. So as you can see from obviously from the first day, there's nothing to compare with, it's 0. And from the second day to the first day, there's a huge change. Just a little bit of inside story. I heard that's because someone was flying a drone that actually interrupted the helicopter fire saving. Anyway. So that's that. So now we know the percentage change. The next step, I have, as you can see on the map here, I have some on the map here. I have some trails and campground information. So what I would like to do is to find out what's the impact for this recreation area because of the fire. So what I will do now is in the analysis gallery, there is a tool which is really useful called Summarize Within. I can summarize within my fire boundary all the trails. And then there is a field called annual usage estimate. I'm going to summarize all the usage within that fire boundary, and also the total length of trails. To use miles. So let's go ahead, run that. Okay, so now I have my my result. Let's check that. So from the result, you can see the summarized length in miles and then summarized usage in a population. So the next thing I would like to do is to find out how many people are affected, how many people living in this area and are affected. So for that, I can use the Enrich layer tool in ArcGIS Pro. It's available both in core and also in business analysis extension, and I can use that and to enrich this area. So I'll just do a quick enrich layer. I can also, just to be safe, I can also first buffer 5 miles of that area and then enrich. So here I'm going to say this is the area I would like to enrich. And then I want to say the variable. So if I start selecting variable, this is what it's called a data browser. So these are all the available categories of the demographic and other type of data that I can add to my data. So I can choose, from here I can choose key facts and go to key US facts, so I can add the population information. Okay? So that's the first part of the demo. So I use the tools out of the box. So let's see. the next year, actually, the year after the San Bernardino fire, we had another fire in San Diego area. So what if I want to do the same type of analysis again and again? So instead of always running these tools manually, I can go ahead and create a model, and then I can just plug in different input and give a different output. Then I can repeat and basically automate that workflow. So what I do here, so this is the fire boundary in the San Diego area. So this time I'm going to create a model. So I go analysis and model builder. Let's give a name to this model called fire analysis. The nice thing about Model Builder is that previously I ran some analysis and they are all available in the history. I can drag and drop from the history and just drag it to my model. So now I have that summarized within tool. I can go ahead and change the input. The input now is the San Diego fire boundary and the San Diego trails. And then I have that part of model complete. I can go ahead and then do a buffer from that, and then drag and drop the buffer tool here. So I can connect the output from my summarize within to my buffer tool as input, and I'm going to say 5 miles. I must be blind here. Here. Okay. All right. So that's the buffer. And then finally, remember we also did the enrich layer. So that's still in my history. I just go click on enrich layer and connect that. That's my input. And then I think I'm done. So let's make it a little easier to see here. Fit to window. So now I have my models. I can remove these things and let's validate and then run it. The nice thing about a model is like a visual diagram to document your workflow, and when you run it, you can actually see which step is running. So whatever turns red, that's currently the step. And there. We have our results. So let's add that to the display. Because it's buffered, so it's a little bit too zoomed in. So let's go zoom out a little bit. That's an ugly color. So let's just check our results. So we can see that I have here my summarized usage. That's from summarize within. And I also have all this population that's from enrich layer. And the polygon is so big because I did a 5-mile buffer. Okay? So moving on, what if I want to do exactly the same thing? Still for San Diego, but this time instead of using Model Builder, I want to create a Python script tool. So, quite simple really. So Python is a scripting language for ArcGIS. So in ArcGIS Pro, we have integrated a Python window that you can basically type in any Python, access all ArcPy methods. You can interactively run it in the Python window. You can access all the layers in your active project. And then you can also run, like ArcPy is the library that allows you pretty much do everything you can do in ArcGIS Pro using Python. Okay, so you use Python mostly two ways. One is to extend the functionality that's not currently available in geoprocessing, and two is to automate your workflow like what I'm going to do here. So I'm going to do a real simple one. So in my toolbox, I say go new, a new script tool, and let's call it a fire analysis. And then I'm going to specify parameters. I know that I need to have a fire boundary input, which is going to be a feature layer. And that's my input. And I also need to have a trails input, and that's also a feature layer. And that's my input, and also I need to have output. It's a feature class. Okay, and then this is required, and this is output. Okay, so the next, let me show you the script I have. So this is a really simple script. I just want to demonstrate the point. So the first part of the script is I'm getting the value from your parameters, right? Your to input and the output. And then I set the environment where to store the data, where to get the data. And then here I run, the summarize within buffer as well as enrich layer, right? So that's the script. So let's now just connect our tool with the script. Okay, now let's go ahead and run this tool. It's not my day today. Okay, let me just double check one more time. Okay. Okay, it should work this way. Okay. I don't know. I don't want to waste time to solve this, but it should just come up with just like a regular geoprocessing tool. I've done this many times. Trust me, this works. So it just open up with the geoprocessing toolbox with so you can input fire boundary and you can input trails, and when you run it, basically it runs the script, does the summarize within buffer and enrich layer, and it's supposed to create the same results. Okay. So quickly summarize what I did. In the first demo, I used add geometry attributes, and then that's when we calculate the size of fire in acres for each day. And then I did add field and calculate the percentage in fire area from day to day. And then I use summarize within, and then to get the impact of the affected area, and also enrich layer to find out what's the total population of the affected area. Okay? In my second demonstration, I start a new model and then call it fire analysis. I drag and drop from the toolbox history, the summarize within, and then I chain and connect these tools in my model builder model, and to do buffer and enrich layer, run the model, and then validate the results. And my third demo, I made a new script tool and call it fire analysis, specify parameters with input, output, and prepare a Python script and with summarize within buffer and enrich layer. I ran the script tool. I wasn't able to validate results, but you just have to trust me on that one. Okay, so moving on to the next one, that's about big data. So big data is very common these days because we have so much large volume of IoT, especially type of data from sensors and various sources. So in my case, I contact this agency called Oil and Gas Organization, and they provide gas price data. So I got for 1 year for the state of California gas price data from the end of, this is a few years old, so from the end of 2010 to February 2020. to February 2011. So it's like 1 year of daily data for the whole state. It's about 2.5 million records. So I want to show you what the data looks like when they deliver it. So they gave me 4 like Excel spreadsheets, and each one is like a quarter of the year. So what I did was, what is the nice thing with the geoanalytics server is that I can just register a folder with these 4 Excel spreadsheets. I register that folder as a big data file share on my server. And then later on, if I have new data come in, I can just dump into that folder, and then the big data file store and file share, when I add it to my portal, it will just keep accessing that file. So for that, I think it's a really very convenient for me. So here's what I did. So I have the data here on my map. This is about 2.5 million records. I can't see any patterns because they all overlap on top of each other. So what I did was I went to you can access all the geoanalytics server tools in ArcGIS Pro. So these tools, I'm running it here. It's actually processing on a server cluster that has the geoanalytics server. So what I did was I went to geoanalytics tools and say summarize data, and then aggregate points. And then my point layer would be the one on my big data file share. Okay, try one more time. Okay, here's my big data file share, and you can see that I have my guest data there. And then I'm going to give it the output. And then instead of, I'm going to aggregate into equal size bins to easy for me to review pattern. And I can give a bin size. And the nice thing about geoanalytics server tools is not only I can aggregate based on the space, the hex bins, in addition, I can aggregate also based on time, because when you have large volume of data, typically it has a timestamp. So I'm going to aggregate it based on a 5 kilometer by 5 kilometer hex bin, also in 1 month interval. So I'm not going to run that. I'll just show you the results. So easier to see it in a smaller area. So this is a Los Angeles area. I used the slider, time slider, to show the pattern change over time through the year. So the price actually first decreased a little and then increased. What the pattern we can observe here is in the West LA area, when the price drops, it didn't drop. So it's the last one to drop and first one to increase. So that's, I thought that's an interesting pattern. Okay, so we're running short in time, but I really want to talk about the next demo. It's actually using machine learning to do some prediction. So my use case here is that I would like to predict the seagrass growth. What's the most suitable habitats for seagrass globally? The data I have is I have U.S. data. I have known data for some area in Florida. I know there are seagrass there. So what are my assumptions? My assumptions are seagrass grow in similar conditions. Okay, so that allows me to be able to use my training data. And secondly, I know that what affects seagrass are some ocean variables like temperature, salinity, some minerals in the ocean. Another thing is I know seagrass seems to be, when you're too close to a dock, that is actually a negative impact on seagrass growth. So I have docks information. I have what they call ecological marine units that collects these information about globally about salinity, all these ocean variables. So I'm not going to have time to do the whole demo, so I want to explain a little bit. So number one step is to create this training data, right? So training data I have for Florida area. I have known seagrass locations. So I need points in that area that has all the ocean variables. How do I get that? I get that by using interpolation. Based on the EMU, ecological marine units, I interpolate, and so I get a surface globally, and then I can extract these variables from that raster and then put it in my training data set. So now I have the training data set. Then I can use, it's very exciting, we have a new tool based on random forest, which is not specifically a spatial analysis tool, but it's proven that it's very useful for spatial applications. So let me show you quickly how I can run that in ArcGIS Pro. So I can go here, and then I can start this forest-based classification and prediction tool. So my prediction type, I want to predict 2 features. And my input training would be the US train. That's the training data set that I have with all the ocean variables. And also, I know in those areas we have seagrass. So I have an attribute called present. Present, it means when it's 1, it is a suitable location. When it's 0, it's not. Because I want to treat it more like in the category. I want to decide, is this point 1 or 0, right? So it's a category. I treat the variable as a category. Then I can provide additional explanatory variables. So the powerful thing about this tool is that we design in a way that it takes either vector or raster, both. So your data can be either format. So I can say that my explanatory variable, I have one that is docks, that is a feature. I know that the closer it is to a dock, the worse it is for seagrass to grow. And the nice thing about this is the distance is actually what matters. But instead of I have to calculate that distance myself, you can just you say, hey, this is the distance feature, and I provide the docks, it will calculate the distance for me. Okay, so then I have other explanatory training variables, which are, I mentioned earlier, I generate these surfaces for each of these ocean variables. So these are in raster, so I can provide that. I'm going to use the marine unit as my input prediction features. Okay, and then I just go ahead and run this. Just for saving the time, I'm going to show you my results here. So this is like whatever you see blue are predicted as suitable habitats for seagrass. The green ones are not. So as we just do a quick review with our eyes, it kind of makes sense because we know that this area is way too cold for seagrass to grow. And then we know in Australia, there's a lot of seagrass, also the same in Southeast Asia. So too bad I ran out of time, and this is really one thing I really like this tool is that to make it easier for GIS analysts to be able to do this type of analysis using machine learning algorithm. And the algorithms behind the scenes is random forest. To keep it simple, it's just it's a tool that based on decision trees. And although decision trees are a very powerful way, but it has a tendency for overfitting. So what random forest does is create many, many decision trees and randomly select a subset of this. So all these complicated process behind the scene, and so we aim to provide an interface that's easier for our analysts to use. Okay? Just to remind you, if you like or do not like our tech workshop, please provide your feedback to us and give us your ideas how we can improve this next year.